Hello, and this video is going to be on lesson 5.1 where we talk about parabolas. It begins on page 241. So the essential question here is, how is the distance formula connected with deriving equations for both vertical and horizontal parabolas? What we want to do is write the equation of parabola using given attributes that use the focus and the directrix. So parabolas have something called a focus, and we also have the directrix. And how does the focus and directrix help us create a parabola? Well, what we want to do is connect the focus and directrix, and we have a point in between such that the line between the focus and directrix are bisected evenly. Now notice that this blue line here is always going to be perpendicular to the directrix, and so when I move this point in between, you can see how the line is always perpendicular to the directrix. Now, in order to create the parabola, I'm going to move this point such that both of these lines are always the same length. And so, as you can see, both of these lines are the same length no matter where I move that point. And as you can see, take a look at what the path creates. The path of the point creates the shape of a parabola. And so the only way we're able to get that is whenever that point, as you can see, these lines are always the same length. That is how you create the parabola. Same length throughout, no matter where that point is moving at. So that is how the focus and the directrix are important for creating the parabola. Now let's go ahead and derive the equation of a vertical parabola. So here we have a vertical parabola because it's facing up. Let's say that the focus is at a coordinate 0p, the vertex of the parabola is at the origin. Now since these are the same length, this point here is going to have a coordinate of 0, negative p. And what we want to do is we want to derive the equation of this curve right here. And that's where we have to use the distance formula. So remember, D1 and D2, these two lines always have the same length, so they're going to be equal to each other. And the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, to find D1, we simply have to take the endpoints of the first line, which is 0p and xy, and we're going to substitute them into the distance formula. To get D2, we take the endpoints xy and x negative p and substitute those points into the distance formula. Now what we're going to do next is do some algebra to simplify this equation. So to get rid of the square roots, we need to square both sides. We need to expand the parentheses by distribution. Here we need to cancel out like terms, move everything to one side, and take a look here. The equation for a vertical parabola is going to be x squared is equal to 4py. And so when we take a look at our table here, this is exactly what we get. We get that the equation for a vertical parabola is x squared is equal to 4py. Now to derive the equation of a horizontal parabola, which is what we have here, what we need to do to begin to derive the equation for a horizontal parabola, first we need to find the coordinates of the focus. Here's the focus right here. Now notice that the focus is always inside the parabola. So if we go back to our video, here's the focus. It's inside the parabola. And the directrix is always outside the parabola. Alright, so the coordinate for the focus here is P0. Now, we want to write down the expression for the distance from a point x, xy to the coordinates of the focus. So we want to substitute these coordinates into the distance formula. So we're going to put x and y here, and basically x2 is going to be p, and y2 is going to be 0. Now we want to go ahead and simplify this. Let's see here. The distance from a point to a line is measured by drawing a perpendicular line segment from the point to the line. So here, the distance from a point to a line is going to be, here is my perpendicular line segment right there. Find the point where a horizontal line xy intersects the directrix defined by the line x equals -p for a parabola with its vertex at the origin. So here's the point right here. This lies exactly on that intersects the directrix, and so that point goes right here, -p and y. Write down the expression for the distance from a point xy to the point from step C. So basically, again, we're using xy. This time my x2 is going to be -p. And hold on a second here. Here, and then we have y here. Okay. Setting the two distances from the same again. This line segment here is going to be the same distance as this line segment, so we can set them equal to each other, which is basically why we set both of these equal to each other. To continue solving the problem, square both sides of the equation and expand the squared binomials. So basically what we're doing here is we're squaring both sides to get rid of the square roots, and we have x minus p squared plus y is equal to x plus p squared. Okay, when we expand the parentheses, we should have 1x squared plus -2xp plus xp squared plus y squared, and 1x squared plus 2xp plus 1p squared. Now we can go ahead and combine like terms here. So -2 xp plus 2xp, well, that basically becomes 0. So we have, wait, hold on a second. When we combine like terms, what we should have is 0x squared -4px and 0p squared plus y squared. And so when we go ahead and solve for y squared, we're going to get that y squared is equal to 4px. Alright, which is the equation that we have here. This is the equation of a vertical parabola, and here's the equation for a horizontal parabola. Alright, now what we want to do is use this information to find the equation of the parabola. So the first thing we want to do is we want to find the focus. This is the coordinate right here, so basic geometry. -8, 0, which is right here. Now the directrix lies on the x-axis, and where x equals 8 specifically. Now remember, the directrix is going to be either a horizontal line or a vertical line. Now, since it's intersecting the x-axis at one point, that means we're going to have a vertical line as our directrix. Now, remember, something very important about the parabola is that it never intersects the directrix. It's never going to intersect it. And the focus is always inside the parabola. So how is this parabola going to be opening? Is it going to be opening up? Well, if it opens up, there's going to be a problem. It's going to intersect the directrix. Once we extend it, it's going to intersect it. So it cannot open up. Can it open down? Well, the problem here is, again, it's going to intersect the directrix, so it cannot open down. If we open to the right, the problem is that it intersects the directrix twice. So the only other option is that it's going to open to the left. And that's exactly what it is. It's going to be opening to the right, to the left. Okay. So since it opens to the left, that means that it's a horizontal parabola, which means we have to use y squared is equal to 4px. Y squared is equal to 4px. And what we need to do is find what p is. And so p is basically the x-coordinate of the focus. And so the x-coordinate of my focus is -8. Therefore, p is equal to -8. Which means that my equation for the parabola is y squared is equal to 4 times -8x. And basically, y squared is equal to -32x. There it is. There is the equation of my parabola, using the given information of the focus and the directrix. So let's go ahead and do one more example. Here, my focus, again, using simple geometry, is at 0, -2, which is right here. My directrix this time is located on the y-axis, and it crosses at y equals 2. Now, since it crosses at just y equals 2, that means my directrix is actually now a horizontal line. So again, I want to draw my parabola so that it doesn't intersect the directrix and the focus is inside the parabola. The only way I can draw that parabola is not if it opens left, not if it opens to the right, not opening up, but the only way is for it to open down. So this is a vertical parabola, which means that my equation is going to be x squared is equal to 4py. X squared is equal to 4py, and I need to know what my p value is going to be. So that means if you look at this, my p is going to be the y coordinate of my focus. So here's the y coordinate of my focus, which is -2. So x squared is equal to 4 times -2y, and so the equation of my parabola is x squared is equal to -8y. There we go. And of course we did these other examples. Thank you for watching.